So I hope you guys enjoyed the coding practice I gave. And in this video, I'm just gonna go through solutions for specifically these four problems and hope that can make sense to you guys and hopefully can help you guys like prepare for final as well. We can look at the first coding question first. So the topic here is like recursion on XML tree. So it's saying report the number of leaf nodes. Leaf nodes just mean nodes that has like absolute like no children. It could be tag node, it could be content node as well in a given XML tree. And this message is just gonna return the number of leaf nodes in a given XML tree. So it's pretty a standard recursion on XML tree problem. So we just like pretty quickly like, code this out. So we could do int count 0, and eventually we're gonna return the count. Count just keeps track of the number of leaf nodes. So first we could check whether the XML tree is a tag node or not. If it is not a tag node, that means T is obviously a content node. And we know for content nodes, we have basically no children. So we just set count 1, and that's pretty much it. The leaf node is just like the root node itself. It has no children and it's a content node. And on the other hand, if T is a tag node, which means it is likely to have some children, but we don't know like whether root node T has a child or not. So in this case, we also have to check the number of children of the root node. So we could do if the number of children equals 0. And in this case, if he has 0 children, that means he's isolated or a single node, and we know it's a content node. We know it's a tag node because it's in the else branch. So it's a tag node that has absolute no children. So what's going to be the count of the leaf node? It's just the root node itself. That's the only leaf node. And on the other hand, if the root node T has at least like one child, in this case, we just have to iterate through each child and recursively accumulate the number of leaf nodes there. So it could be I0, I is less than the number of children, I plus plus, and we could add up those leaf nodes in each individual subtree or children. So count plus equal. This is where we can recursively call this method to calculate or to count number of leaf nodes for each child. And yeah, that's pretty much for these first problems. So it's similar to the homework problems as well, and it's like a standard recursion or XML tree problem that we could potentially expect this level of difficulty on final as well. So yeah, hope you guys, yeah, it's really standard problem. And the more important part of the final will be data structures. So for the rest of the three problems, they're all about data structures. And let's look at the first data structure problem as well. So it's saying divides each individual or each integer in a set by 2. And I added a specific note here, like this is actually tricky, which is not really tricky, but there is something you have to be aware of or to watch out for. And so first of all, we notice we are modifying this set. So any like iterative method like for each loop doesn't really work out here because you cannot like modify your elements in a set while you're like using for each loop. So alternatively, we could use remove method or remove any method. So use remove any method, temporary set to keep track of those numbers we're handling with. So it's going to be set new instance. In this case, we create a temporary set and we can start removing elements from the set and divide each integer by 2. So it would be so while set size squared or equal squared than 0, we just remove any, it's called remove. So remove an integer set. I'm gonna call it like number. So it's like which needs to divide integer by 2. And you can add this integer back to the ampersand. To add number to it, and eventually after we divide each integer by 2 and add it back to the temporary set, plus we have to do it just to like call transfer from method, which is like temp. So you could do set transfer from and to transfer all of the data from the temporary set back to the set we're modifying this. And there is one thing that could be tricky here. When we add number back to the set, it's likely that the number is already in your temporary set. I mean, it might be like why? So like each individual number in the original set, they're distinct, they're unique. But after I call like the dividing method, why would I have like duplicates? Why would I have like the number, the same values? It's all about the integer division. So if you think about if you have number, say 5, divided by 2, the value it returns is 2. On the other hand, if you have 4 divided by 2, that's so 2. So short or in short, we could have 5 and 4 in the original set, and these numbers are like distinct, they're different, they're unique, right? But if I call it divided by 2, both 5 and 4 become like 2. So there might be like conflicts or duplicates in the set. So in order to like safely handle these, we could just like add additional condition here, which is like if m contains, we just need to check if the number is already in the set. So contains number only if the number is not in the temporal set, we add this number to it. And this is the tricky part of this problem. So if you divide each integer by some number, it's likely that different numbers can end up being the same number after division. So it might be something to like watch out for as well. This is like the second problem, where first thing is to keep in mind, if you modify something in a set, always you remove any instead of for each group. And another caveat is the precondition of set. Always make sure that before you're adding anything to the set, make sure like the number is not present. Make sure the number is not present in the original set. So that's like the second problem though. The third problem is about a map. So you're given an array of words, and the goal is to find the star word. What is a star word? Star word is defined by the word with maximum number of appearance, or the words with the maximum number of counts. And so we're saying report the star word given with given array of words, and report any star word is fine. Reporting any star word is fine if there's a tie, like two words, they have exactly the same number of occurrence. So here we are thinking about using the map data structure. So what would the map be? What would the map function in this method though? So we could do a map frame here. Any implementation is fine. Now, so we have to make it for it. So this map, the goal of this map is to keep track of each word with its count. So this map is gonna store something like key value pairs, like we have word, like solve one, and the count might be like 10. Could also have another word like solve word 2, counts as like 9 or something. So the map is basically a mapping relation between word and its number of appearance, or number of counts, or number of occurrence. It's an array. With that in mind, you should build a map really fast. So first thing we have to do is just to build a map, to iterate through the array. So we could do int I. That's not the way to. I'm just gonna use operation for iterating the array because we're not modifying any elements in the array. So we could do string word for each word in the words array. Now we just have to like build a map. So think about the word. If the word is not in your map, or if the map does not have the key word, what does that mean? That means this word is like pretty much a new word in your map. So this new word, we could just do add this word, and what's gonna be the number of occurrence of it? It's gonna be 1 because this is a new word and this is the first time you see this word. So number of currents or the count is going to be 1. And on the other hand, if the map already has this word, what you're going to do is just to increment the number of counts. So you could do map. There's a method called like replace value. So you could replace the old count by incrementing it by 1. So the map, the value, to pass in the word, to map the value word is going to return the old or the previous count for this word, and we just have to add 1 to it, and that's going to be for a map. So after we set up the map, we just need to find the word is the maximum number of appearance or the maximum count. Keep track of the word, which can be our star word. The star word, and eventually we have to return the star word. And also we need the maximum counts. So we need to keep track of the maximum count to like keep updating our star word. So we just have to iterate through the map by using f.pair. So it's a pair of string mapping to an integer. So we pair the map. And if the pair or if the counts is greater than the maximum count, which means pairs the value is greater than the maximum count, that indicates this specific word has a greater number of count. It has a greater count. So we could update our word to be the word we're processing as well, and to be the word we're processing. So it could be the star word is equal to the pair key, which means this word, it has a larger number of counts. And don't forget to like update the maximum count as well, because you need to keep updating the maximum number of count or the maximum number of occurrence to be able to like keep updating with the star word. So it will be better. And after we keep updating the star word and the maximum count associated with it, eventually we just have to return star word. And that's like the third problem of the final coding practice. Is kind of it's not complicated, but it's like kind of like bigger coding problem. Might not be on the final, I guess, or it could be like, but it's not really hard to say. It's not really hard to solve. You just have to keep in mind which data structure is the best, is most suited to the situation where you keep track of the word, but also the count associated with the word. So a map could be a really good fit for this situation. And you could go to the last problem, which is about stack. And so it's saying a parentheses sequence is valid if all the parentheses are matched. Or in other words, every opening parentheses is properly closed by another closing parentheses, and there is no extra closing parentheses as well. And given the sequence of open or closed curly braces, I should just like said it's like curly braces, but So it's a sequence, either open curly braces or close curly braces. And message is just to report if the current sequence is valid or not. And notice we have a parameter sequence. So this problem we can also practice with the syntax associated with sequence as well. So let's just say is valid. We just have to report whether the parentheses sequence is valid or not. So true, and we'll return as for as well. So we could think about this problem by actually drawing a couple of examples. So we could have parentheses, like open parentheses and close parentheses. And do the parentheses match here? Yes, obviously. And it's not a tricky question, or it's even not a trick question though. So let's consider this case where we have two parentheses. So this example, we can see it's also valid because each open parentheses is properly closed by another closing parenthesis. And what would be a counterexample in this case? So it could be something like, let's consider this example. Is this sequence or parentheses sequence valid? No, because even though we have same number of closing parentheses and open parentheses, the parentheses don't end up matching really well. So these two, they're like matched, right? But after that, we start with like a closing parentheses, which is weird. So this is not valid. So let's consider about the algorithm. We're given any sequence of like parentheses like this. How could we use specifically a stack to handle this situation? So keep in mind for stack is like LIFO, the structure. That means it's like last in first out. So whenever you see an open parenthesis, you can push these parentheses into the stack. Another open parentheses, push it to the stack. If you see a closed parenthesis, that means these two specific parentheses, they're matched. And what we could do is just to pop the parentheses in your stack, which indicates that these pair of parentheses, they matched. They are perfectly matched. And you can see if we have another closed parentheses, which keep popping the parentheses in our stack. And as you can notice, here we see these two parentheses, these two pairs of parentheses matched. Like these parentheses, like closed parentheses, which is not valid, which means it's an actual like closed parentheses. Or we could say it's not open properly by an open parenthesis. So in this case, sequence is valid. So after we think about these specific examples, we could go ahead and solve this problem. So what we need is a stack. It's a stack of character using any implementation is fine. And what we need to do is just import it first, obviously. And one sec. All right. All right. And we just have to iterate through the sequence of parentheses first. Time to isolate sequence links. So let's retrieve the specific parentheses at position I first. So our sequence entry is entry I, and we can see, oops, if the parentheses is open parentheses, we can just add this. We can just push the open parentheses to the stack, which means there is one pair of parentheses which is not currently closed yet. So push whenever you see an open parentheses, you push it to the stack, which indicates there is an extra pair of parentheses that has to be closed later. We notice in the contract the sequence could either be closed or open parentheses. If it's not an open parentheses, it must be a closed parentheses. So in case of closed parentheses, this is where we have to be kind of careful. If stack the links is equal to 0, let's think about this case. So the stack is empty, which means there is no open parentheses that is waiting to be closed. But in fact, you see a closed parentheses, which means you have extra closing parentheses. If the stack is empty or the length is equal to 0, that means there is no open parenthesis that is waiting to be closed. What does that mean? It means there is an actual closed parenthesis, which also means the sequence is not valid. Do is valid or but if the stack is not empty, that means we have to pop one open parentheses, which indicates like one pair of parentheses that are matched. So we could do that. And after we iterate through every single character or braces or brace in a sequence, we also have to check whether all of the open parentheses are closed. So what I mean by that is like if that is greater than 0, if the length, if the stack is not empty after you iterate through the sequence of parentheses, that means what that means is there are extra open parentheses. There are extra open parentheses that haven't been closed yet. An example could be like have like 10 like open parentheses, but only has a couple of like closed parentheses. So you could call pop, 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 pop. But after you iterate through this sequence of parentheses, stack is not empty, which means there are extra open parentheses. They're not closed yet, which means the sequence is not valid. So it is valid. And we can return a valid. It's valid at our end. So that's really pretty much the coding problem I had. And if you're interested, there is like a legal problem as well. It's called valid parentheses. It's going to be more involved than this problem. And if you want to try that, I definitely recommend. But hopefully, I hope this the final code practice I made could help you guys prepare a little bit for the final coding problems, and to also have a sense of like what the coding problems would look like. So it would be some recursion problem, but the main focus would be data structures, how you can pick the most suited data structure to implement your tasks. So thank you for watching, and let me know if you have any questions for this problem. Yeah, pretty much that's it, and hope you guys do well for final.